But there are some sensors in your phone that can actually save your life. Imagine that you're climbing up a ladder and you're drilling a hole and the bit gets jammed, right? The power drill would just yank and make you lose your balance and possibly even fall from the ladder. Well, through a gyro, right, we're able to detect this yanking and remove the power before the whole drill starts to rotate. He pivoted ST to making complex mixed signal chips, right? Analog, digital, and power. And he also had this intuition that it made sense to get into the MEMS business and start the MEMS. And he did it at the right time when there was the inflection point, the starting of that business. Also because MEMS was already being researched since many decades around the world, but it was never really brought to scale production. I was actually in a police department and working with people, doing patrol, doing reports, doing a number of things, and that really opened up two aspects.
3 months after that war, I had the operation full on heart. And then after the operation was done, they installed a Medtronic device that goes, I'm not sure you can see, but you can see it here. And this Medtronic device is inside here. What's your spider sensor saying to you will be the next big driver or the big app or the big mover of MEMS manufacturing?
We are still, I should say, before the inflection point, but it's inevitable that some kind of eyeglasses, eyewear would become prevalent and commonplace. If you don't do the hardware right, you forget about the software. And one of the problems that we often had was how hard it was to find the floor where people went. According to the FCC, that in the end accepted to roll out this service, in the US alone, more than 10,000 lives are saved every year. We introduced the smallest accelerometer in the market, right? We introduced a smaller air quality sensor. The trouble is, we don't know.
Join us as we welcome Marcellino Gemelli, a leading voice in business development shaping the semiconductor landscape.
With extensive experience at the forefront of global electronics, Marcellino's expertise is unparalleled in identifying new opportunities and fostering key collaborations. From his impactful tenure at NXP Semiconductors to his current role at ICES Global, he consistently bridges the gap between groundbreaking technology and commercial success.
Get ready to explore the intricacies of market expansion and strategic vision in the high-tech sector. Let's dive in.
Hello, and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri, and it is with great pleasure today to introduce you all to the world of MEMS and sensors. So whether you're an industry veteran or someone who's just curious about semiconductors or MEMS or sensors, this is your podcast. I have a small little favor. We've just hit that 2,500 subscriber mark and 100,000 views. Click that subscribe link because the more followers we get, the more interesting the podcast becomes and more dynamic the discussions will be. Just like our special guest today, I have Marcellino Gemelli, an old friend of mine who is the head of business development at Bosch. And it's been interesting because in his days that I've known from his ST days and Bosch days. So without further ado, Marcellino, welcome to the show.
Isn't it great to be here, right? It's
Thank you.
Lifelong dream to talk about MEMS semiconductors in Silicon Valley.
Yes. So it's interesting, when you look at the history of MEMS, and just for people that are not aware or that they don't know what MEMS are, could you give us a brief background on what is MEMS? What is MEMS and why is it so important?
Well, many people know that semiconductors are part of our life, right? Sure. They are the tiny little switches that run all our electronics. And that's where we use the semiconductor properties of silicon to make things work, essentially to make switches, memories, and processing. In MEMS, we're using the mechanical properties of silicon, which is a wonderful piece. It's a wonderful element where you can make springs, you can make masses, you can make a resonating device to generate sensors and actuators. So in other words, you are the interface between the world, the real world, the physical world, and the digital world.
Right.
So MEMS stands for Micro-electro-mechanical systems. So these mechanical systems are based on silicon.
Mm-hmm. There you go. No, perfectly said. So, Marcellino, from your perspective, could you give us a brief overview of your path from studying electronic engineering at the University of Pavia? So I want to know about that story first. So what made you first go into electronic engineering at the beginning at the University of Pavia?
I was lucky. I was lucky because many kids at high school, I know because I have a couple of teenagers, right? It's sometimes it's hard to find your path, right? And I always knew that I wanted to get into electronics. I started tinkering with electronics since I was 10. So for me, it was a natural path to get into electronic engineering. Nice. And I chose Pavia because it was the closest to my home.
Okay, all right. So you didn't want to leave home, but then you ended up leaving home.
Yes. Well, I was actually staying on the campus, but it was geographically the closest. That's what you get to do in Italy, right? Sure. I guess we are more family-oriented.
Sure. So then after your electronic engineering, you then completed your MBA at MIP to becoming a business development leader at Bosch SensorTech. Did the MBA, was that straight after your electronic engineering?
No, I did what is a typical career path to start in a company, work your way into understanding how the corporate world works, and for 5 years. So you get to learn how large companies engage with smaller companies, right. how the dynamics work, and then you get into these executive MBAs that usually during the time where you're still working, you're working and studying at the same time, and that's, I think, the best bang for your buck. Also because often you get to try out in your current job what you're learning at the MBA during the MBA experience.
Right. No, I've had to say it's quite a similar experience. Doing those type of courses, it's quite funny because while you're sitting there, you're actually saying to yourself, "Oh, hold on, I lived this, and this is the theory behind the practical behind what I do on a day-to-day basis." So I find it, very, very appealing. And what would be intriguing to know as well, Marcia, every top executive that I speak to, similar to yourself in your role, with the responsibilities that they have, normally there's been someone in their lives who's been an inspiration or someone that they've looked up to or someone that's given them the guidance to go on a certain path. Do you know who that person is for you?
I have several, but I can start from my early career, right? Many people in the industry know him. His name is Bruno Murari. He was at ST, the innovator and leader, the driving force, the energy that most of us engineers at the time looked up to as someone who could revolutionize the industry. And he did, right? He pivoted ST to making complex mixed signal chips, right? Analog, digital, and power. And he also had this intuition that it made sense to get into the MEMS business and start the MEMS.
He's the first person to go into MEMS?
So he put together a team that included me, right? That I was honored to say, hey guys, let's look at the mechanical properties of silicon, with everything that entails, right? The ability to reuse old semiconductor processes, the ability to reuse the competences that you have and the contacts that you have with the customers. And he did it at the right time when there was the inflection point, the starting of that business. Also because MEMS was already being researched since many decades around the world, but it was never really brought to scale production. And so that was something inspiring. And in the end, it created a team that I was part of, where we pivoted and made it happen.
Where was this in Italy?
This was in a town just outside of Milan called Cornaredo, which was the design center, the innovation center of ST Micro.
Wow. What really intrigued me studying your bio was your experience in the Italian army.
Yes.
Tell us more. I love this. I mean, the reason why is, my father he was also in the military, so he carries a lot of values that passed on to us, to his children. So I presume a lot of values you must have gained from the military that's made you the man you are today.
Well, I have to say it did shape me. So in Italy, back in the day when I was growing up, you had the mandatory draft. So you had to go to the army. But for a number of people, you could volunteer and be selected to enter some special corps. And I said, well, since I have to do it anyway, right, should I go somewhere and get little out of it, or volunteer in a special corps that in my case was the Carabinieri. It's the Italian civil and military police. So in the end, I ended up entering this academy, and I served as a policeman, and which brought a totally new perspective in my life. Right, I was in touch with people. I wasn't in some random army assignment. I was actually in a police department and working with people, doing patrol, doing reports, doing a number of things, and that really opened up two aspects, right? One, the ability to relate to people, and the second is the service aspect, right? And this service is still alive today, because in Italy they say once a carabiniere, always a carabiniere. So I am still part of that organization right now. Wow. And even here in the San Francisco area, I tend to gather some of my former colleagues, right? And we sometimes put on our uniforms for some special events that the Italian consulate has.
Wow.
I have to say, I still fit in my uniform.
Really?
From 30 years ago. So that in itself is an achievement.
Wow. That's I find that very inspiring. And, one of the, I saw a clip not that long ago, well, quite long ago, and it gets repeated always. And Simon Sinek, you might know the gentleman who talks about leadership, he refers to how the commitment of a team is the true form of success, and that it should be the key goal of a leader to put their people first and to look out for the people before their customers. So he uses an analogy of the Navy. So in the Navy, they have a terminology that they call each other. They call each other not by name. They call each other brothers and sisters. So, and that methodology actually replicates on the battlefield sometimes. Or if he saw one of his colleagues get off the boat or whatever, that person will jump up and save that person's life in any means possible. So those type of values I see in the type of military perspective is an element of a community, an element of belonging, and etc. Do you see this methodology as one of the key criteria for a success of an organization?
Absolutely. And to quote Simon Sinek as well, right? There was he made a paper saying leaders eat last, right? And this is so true, because you have to put your team in front of yourself as a leader, because they are the ones who actually operate, right? They are the ones who are actually doing the work, and in many ways, if you get this right, you really become the leader that everyone aspires to have, which is encourage you, stop you, or get out of the way, right? And that is the best way of doing leadership. Of course, it doesn't work 100% of the time. Sometimes we are humans,
Sure.
but that is something that we all aspire to.
Sure. So at that time, so run through with me now. So in terms of your groundings in the semiconductor world was at ST Microelectronics.
Yes, I started there.
You started it. And of course you were part of that inflection point, and the let's say you were in the juicy time, as one would say. What made you transition to Bosch?
So I was always lucky to be in groups where we were starting new things. So at ST, I was part of the team that was introducing digital design to analog designers. So let's say a semi-automated design process to people who were chiseling away on the sizing of the transistors. Right. So that was new. And so you bring in a new competence to the team. There's both a technical and a cultural aspect, right? And again, introducing MEMS as part of a new product generation. I then moved to US with ST as again to establish a new market in a more traditional semiconductor space. In that case, it was in hard disk drives and providing chips for hard disk drives. And at some point, there was the opportunity to continue the career, but that would have meant within ST to go back to Europe. And me and my family were not quite ready to do that. At the same time, Bosch was looking for someone here in Silicon Valley to start their consumer electronics, consumer MEMS side of business. They were already an established player in automotive, of course, but they needed someone in the consumer. So it was, in a way, another startup opportunity. So that's why I made the transition. I still have a lot of friends at ST. The market is small. We all know, but it was the right time to move.
Wow. Marcel, this is going to sound very interesting because I've experienced it just recently. Okay, so you mentioned that you left Europe, you left Italy to move to the US, and then you decided that you wanted to remain in the US with your family. Why? What made you say this is home to an extent?
Again,
for my second home or home.
Yeah, well,
but home is Italy. Or, I don't
know. My heart when I think of home, and I still think of Italy, of course. That said, at least from a professional point of view, when you are in semiconductors, when in electronics, there is really no better place than here.
Absolutely.
Right. The amount of innovation, you can wake up one morning, have breakfast with someone from a startup, get your work through, then maybe go to an event in the evening, say whether it's a deal flow from a VC or helping out, mentoring some younger people starting off, and the next day you get to repeat it, and the next day you get to repeat it again. There is no other place in the world where there is this exchange, this constant exchange. Now, if it wasn't for this, right, of course, then Silicon Valley, of course, it has beautiful weather, right? But this is the ticket that you pay to get to be into this highly dynamic, always innovating side. If you like this is the place to be.
Yeah. Why is Europe not like that? Well, I mean, cause I'm from England, so I was born and raised in London, England. And the reason why I say what you just said hit me so hard is I always knew San Francisco. Last year, I spent more time in the Bay Area and spent quite a long amount of time on Stanford doing their executive program on their campus. And that's exactly the life I experienced. I'd be studying in the day, meetings in the afternoon, dinner at night, meeting this VC, that connection, and there's just a buzz and everyone wants to help each other and grow. And I even ponder that look who's here, NVIDIA, Apple, all of the greatest companies of the world are based in this area. And it's like there's some sort of like electric energy that's just dragging these places in. Why isn't Europe like
that? I've often asked myself, I mean, there are some pockets of real innovation and competence that spring up anywhere. And not just in Europe, right? In different places in the world. After all, we're all connected, right? And we're just one Zoom call click away from each other. But there is a certain energy, the ability to rub shoulders, literally rubbing shoulders, and have these personal interactions, personal conversations that go beyond the formal context that an email or a video call can provide. So there is something to be said about the natural proximity, and if we look at Europe, some people argue that the glue bringing all this together are things like the VC, the availability of capital. That could be true, but I instead believe that there's more to it than that. There's actually something. People say something in the water, in the air, but it could be something that it's more of a self-fulfilling prophecy. Right? You come here to seek that. And you don't give up until you make it happen, right? And if you're not into it, you just leave.
It is remarkable. Thank you for the insights on that, Marcel. So look, I want to go into Bosch. I want to talk about Bosch in specific in this situation. Do you prefer me to say or refer it as Bosch? Because I know we work with Bosch. There are major members in both power and specifically in the power area. Is it Bosch or is it the Bosch SensorTech?
So here in US, I'm physically part of Robert Bosch LLC, which is the US entity. But for most of my time, I work for Bosch SensorTech. Bosch SensorTech is a wholly owned subsidiary of Bosch, headquartered in Germany, and it's a fabless company, even though Bosch has fabs. But as Bosch SensorTech chooses the fabs that are most conclusive to the work, which includes the Bosch MEMS fab. But when it comes to ASICs, right, we rely on many ASIC vendors and for the back end. So it's that's another nice thing that I like, right, about the dynamic nature of a fabless company that is an integral part of a much bigger parent company. I think this was a very wise choice that Bosch made, and almost 20 years ago at this point. And they said, in order to go after the consumer electronics market, we need to change the way that we are integrated. Bosch is normally very much vertically integrated, especially in automotive. But when it comes to consumers, said, okay, let's create this organization and let's let it be more free when it comes to outsourcing manufacturing, outsourcing design, outsourcing, and also let's spread it out around the world. That's why I'm based here, right? Even though the headquarters is there. So I think that was a very wise choice that proved out to be a winning choice.
And of course, it is notorious. There's a notorious phrase known for Bosch: "Invented for life." The motto. How do you see this manifesting in the MEMS and sensor space that you're overseeing in specific?
I mean, it's not just a motto, right? We at Bosch, we really believe it, right? It's part. It starts as early as the onboarding process, right? We look for people who actually not only understand it, but are aspired to that, and we give a number of examples on how. Or what we mean invented for life. And this goes across all products of Bosch, right? All products, from the appliances to the power tools. For us in the MEMS field, of course, we are in many consumer electronics devices. And in some cases, right, these sensors actually help you have a better life. Take, for instance, the accelerometer, right? The accelerometer is used as a step counter, and the step counter reminds you that you need to walk 10,000, 15,000 steps during the day. Whatever your target is, it's an accelerometer that helps you remind. Now, this may be simple, right? But there are some sensors in your phone that can actually save your life.
Yeah, that's true. I'll explain to you that what MEMS actually has done for me on a personal basis, not only on a business front, but also on a health basis. But yeah, I mean, small things like that play a massive role. And with Bosch employing 90,000 R&D associates, including 48,000 software engineers, this is a city. Yeah, I think it's bigger than some cities in the world for sure. How do you see this scale translating into innovation in sensing and IoT?
There is a tremendous amount of competence at Bosch. Right? That's one of the key factors of what makes Bosch great, right? In itself, this constant this constant desire of improving your products, right? On improving the engineering behind the products, the building of IP, the implementation of IP, the selection of the best technologies out there to integrate within the Bosch family of inventions. And this all goes back to the founder, right, of Bosch, Robert Bosch, right, who was exactly like this, right? He was a highly competent, technical, but at the same time entrepreneur and visionary person whose inspiration still lives with us today.
Wow. Yep. I should recall, even when I was back in England, always we used to see, even if you get it was notoriously known, the power driller with Bosch, and that it still is. That must be one of the still market leaders out there in terms of utilities. Or what would you say is that the biggest well-known thing from your perspective when you hear the name Bosch?
Well, there's of course we are a major player in power tools, in appliances. That's where people often see our brand. But we are also tier one suppliers in the automotive space, in the industrial space, right? A whole number of industrial systems are actually built by us. But you mentioned the power drill, right? And that's another example where a gyro, right? A gyroscope can actually help you save your life. Imagine that you're climbing up a ladder and you're drilling a hole, and the bit gets jammed, right? The power drill would just yank and make you lose your balance and possibly even fall from the ladder. Well, through a gyro, right, we're able to detect this yanking and remove the power before the whole drill starts to rotate.
Wow.
So that's an example of
how
MEMS can save
your life. Yeah. All right, so let's talk about MEMS saving our lives. I was diagnosed with a heart syndrome 2 years ago, and it kept on giving me cardiac arrests. So then I took the year off last year, but a few months before, and it's actually not with Bosch. It was at a MEMS World Summit that we hosted, and I gave a Hall of Fame to a lady who's supported us quite hectic. You might know her, Seni Laxonen.
Yes,
from Murata. 3 months after that award, I had the operation for lung heart, and then after the operation was done, they installed a Medtronic device that goes. I'm not sure you can see, but you can see it here. And this Medtronic device is inside him. So I made the announcement. I said, I'm done from the business. I'm going to spend some time with my family for the year and see what I can do to enjoy life. When I made the announcement, she sent me a message. And she said to me, Salah, if that's the Medtronic link too, I need to let you know that there is a Murata accelerometer installed inside, developed in Finland by my R&D team. 3 months after.
So it's literally in your heart.
It's literally in your heart. The MEMS is deep inside. That just shows you how the impact the MEMS community is having in the world, and people take it for granted. This is the just like you said, the walking situation. Everyone now is checking up on their walking now, right?
Yes.
So they check, they say, look at this, I did 10,000 steps, 20,000 steps or whatnot. But they don't realize that those numbers come from the work that you and your company and other companies are doing in the MEMS field out there.
Yes. I mean, there are other cases. The first applications in automotive, the first MEMS application were for airbag accelerometers, right? So when you have a crash, it's a MEMS accelerometer that senses the crash and deploys the airbag. So that's another way to possibly save your life. Another thing that many people don't realize is, why is it that in the last 20 years you have all these SUVs, these high-performance SUVs? While if you recall, I mean, you're from UK, you might recall that Range Rovers on a highway, you couldn't really drive them too fast, right? Because they had and they still have a high center of gravity, right? So they are intrinsically unstable. But through MEMS gyros and MEMS accelerometers, now you can do things like torque vectoring and other applications that make the SUVs more drivable, to the point that now you have high performance SUVs that drive like sedans, right? And that's totally transparent, and that's only thanks to MEMS. The center of gravity didn't move, right? It's still there.
Wow.
But thanks to that, the cars are more drivable.
Wow. Even I think that when you look at even like the modernization of cars, I saw a video. I think it was like the Neo car. I'm not sure if you've seen this video. And the CEO of Neo is with another German gentleman. Can't remember where it was from. They sit in the car, and they had a tower of champagne glasses, and they're driving the car, and there's bumps, and not one glass falls off. That is definitely MEMS and sensors involved in that.
I'm sure there is. There has to be at least a MEMS. There must be also a ton of actuators, but
definitely a lot of MEMS were involved.
Knowing how to drive those actuators, I'm sure it's coming from MEMS.
From MEMS, yeah, it's truly remarkable. So Bosch is, of course, aims, going back to in terms of the next element I want to talk about, aside from the automotive world, which is all the healthcare world. I want to go and talk about IoT and AI strategies, which is, of course, AI now, you cannot sell anything if you don't mention AI. Bosch aims to facilitate connected living through AI-driven solutions. That is the word now. In what ways could you share about Bosch's MEMS products that fit into the larger IoT and AI strategy for today and the next 5 years or so?
So it's interesting because AI is the hype these days. Sure. But it's not really a new technology. The ability to use neuromorphic computing to inference, data in to data out is not new, right? That's been around for decades, and before this hype cycle, Bosch and Bosch SensorTech specifically, we were already and we still are implementing some AI algorithms, these neural algorithms on the edge itself. So that is the key, right? Why are we doing that? You can imagine that if you were to transfer all the data that a sensor collects constantly to the cloud, you will need a lot of power, a lot of bandwidth, and if you need to take some decision very, very quickly, like say in the control of of a car or control of a thermostat, right? The time for the feedback loop would be too long, right? The latency. Right. So in order to address power and data throughput and latency, you put a lot of the processing on the edge, so that you can identify on the edge some specific events through AI algorithms that do pattern recognition of some sort, and only transmit the trigger events. So, for instance, if you have an edge device like an accelerometer that needs to sense a specific gesture, say, suppose that it's in a smartwatch and needs to sense a specific gesture. You don't want to transmit all the data continuously waiting for that gesture. You just keep the processing there until the gesture happens, and then you send the trigger, which could be, turn on the screen and turn on the radio.
Right.
So this brings real benefits to the IoT. Again, you lower the power, so smaller batteries, you lower the latency, and you lower the need of all this communication.
So, based on, of course, all of these unique perspectives that you've portrayed to us right now, Marcellino, from your side of things, when we look at the inflection point of MEMS, we'll just say sensor, but let's talk about MEMS because this is in the heart for us, right? Of course, the key drivers, of course, the automotive market. And then we had, of course, mobile phones, right? How many mobile phones? And the market cap, of course, there was a cap. If we say, if there's, I don't know, God knows, 8 billion people, for example, and each person has 3 phones, right? That's 24, right? That's the market cap maximum that it can hit. And I think the stagnation of MEMS has happened over the past. I started my MEMS platform in 2010. I would say just pre-pandemic, it started to become quite stagnant. And then, of course, you had the wearables come out. They started some momentum. But it's not a big killer application per se for MEMS manufacturing. What's in your gut instincts? What's your spider sensor saying to you will be the next big driver or the big app or the big mover of MEMS manufacturing?
In the time period that you analyze, right, from 2010, something really magical happened, right? The number of smartphones increased to, say, 1 billion smartphones per year, and there was an increased adoption of MEMS, right? So there used to be just an accelerometer, then a magnetometer, then a pressure sensor, then a gyro. So in that time, right, in those 10 years, we were living in a market that was whose products were growing adoption in a growing market.
Right.
So there was the best scenario. To your point, now there is you don't have such a dramatic growth in smartphones, and the content of MEMS right now appears to be flat. So you have a solid, but not growing. The market is not growing that much, right? CAGR is in the single digits. Now that typically is a problem in semiconductors because you need solid growth in order to fuel your R&D. Otherwise, your returns are just diminishing. Right. Now that said, you mentioned that there, wearables, of course, are not as big as smartphones. But nevertheless, they are growing faster than smartphones are.
Right.
And there are other wearables. And think about the TWS, the hearables. If we take a high-end TWS device, there's actually 5 sensors in there. There's 2 accelerometers, 2 gyros in the devices itself, plus 1 accelerometer in the case. So although there's fewer earbuds being manufactured, you have double the content of what you have in a phone. So that gives us hope. Now, moving forward, right, I think it's hard to imagine a market where you have that is as big as a smartphone, right? But there are there are pockets of growth that are very interesting. And in the smart home space, right? In the wearable space, think about AR, VR. We are still, I should say, before the inflection point, but it's inevitable that some kind of eyeglasses, eyewear would become prevalent and commonplace. Maybe not for the use cases that we're thinking about now, but for other applications like audio enhancement, right? There are these this year at CES we saw these glasses that provide an audio enhancement that almost work like a hearing aid, right? So for that you need plenty of microphones, MEMS, of course.
Right.
You may need MEMS speakers, right? That so. I'm not too worried about the growth of the MEMS industry in itself,
Right.
as much as probably I share your concern about the fact that the existing products we kind of reached a plateau.
Right.
So I'm still bullish on MEMS, even though we're flattening out in the areas where the adoption is 100%.
All right. Now, switching, so talking about the adoption, one of the key points to point out in the MEMS community is the plethora of competition that there is and the landscape as a whole. I'd love to know Bosch's differentiators. So how does Bosch distinguish itself from the competition? And are there specific features like reliability, power consumption, size, or integration that stands out for you?
Well, I don't want to go into the advantages, like the USP, the unique selling points of each of our product. But overall, I want to underline that, and this touches a little bit on Bosch's core innovation approach, right? We like to really deep dive on the technology itself. We vertically integrate, right, from the core technology, let it be MEMS or tunnel magnetic resistance or other forms of MEMS fabrication, all the way to the application and beyond, right? Because as Bosch, we're not just we don't just make MEMS, but we make a whole number of products, like you mentioned, right? From automotive to power tools to appliances. Yeah. So we really put a strong emphasis on the end use case, and many times we have that competence in-house. So not just because we sell internally, because we can sell to wherever we want, especially externally to Bosch, but that gives us the domain competence, the domain knowledge. And so you mentioned healthcare, right? Healthcare is one of the areas that we are looking at. Okay. There are untapped use cases where MEMS could favorably play a big part. Think about these continuous monitors of motion of analytes in your body that require maybe even just an accelerometer to wake up, and these oftentimes are disposable devices. So the volumes there are huge. So again, deep technical knowledge, domain knowledge, and of course innovation. We introduced the smallest accelerometer in the market. Right, we introduced a smaller air quality sensor, the particulate sensor in the market. Right, so these unique selling points really help you to pave the way for business success.
Marvelous. So, thanks for elaborating on the initiatives and where you see Bosch going in the forefront. What's also interesting about you as an individual, you're also involved in the startup ecosystem and angel investing. So you're an advisor to tech startups. You're also an angel investor. How do you see collaborations between large organizations, like your Bosches, for example, and then these nimble startups driving innovation in MEMS, sensors, and IoT, for example?
we again, another blessing that Bosch has, especially here in Silicon Valley, is the fact that we have a Bosch Ventures team. And this team, it's a small team also based here in Sunnyvale that is constantly exposed to deal flows.
Okay.
Right. And we often compare notes, right? If they see a company that's in our field, they call me up and say, hey, can you come and take a look at them and see, what their technology is, what their application is? Can you, can you give us another perspective on their business model? And at the same time, through them, I might find some hidden gems, right? Early hidden gems of some people who are really betting everything they have, right, which is their time, their money, and their talents, right, into accelerating a technology that would have taken us Bosch forever to implement, right? So we engage through my role as business development. It also includes things like corporate development, right? The scouting for new technologies to bring into Bosch. And some of these things happened in the past, right? Bosch has made some select acquisitions of technology companies, and therefore expand and enhance. Of course, then from a professional point of view, you are exposed to so many companies that sometimes you inevitably invest in some of them. Of course, I always have to be mindful that my personal investments as an angel investor have to be something which is not in conflict of interest to Bosch. And that's normally very difficult because Bosch makes everything, right? So sometimes it's difficult to carve out. But that's another way that I see of giving back to an environment that has given so much to me.
Respect. So from your side then, here's another interesting one that I'm going to ask you. I'm going to be intrigued to hear your perspectives, but you'd have to choose between software and hardware in terms of prowess of Bosch. Which one is the most strongest part at Bosch? Is it the hardware or is it the software?
I would like to say that it's both, right? We have strong competencies in both, but we also like to think, not just Bosch, but us semiconductor guys, right? We like to think that we have that our technology is the the hardest manufacturing process is semiconductors,
right?
So hardware is hard for us,
yes,
and it's in a way it's a differentiating factor. If you can do the hardware right, then you get a chance to play with the software. Right. If you don't do the hardware right, you forget about the software. There's
soft.
You cannot overcome your hardware limitations with software.
Fair. So the other key thing I wanted to actually elaborate, you mentioned a very lovely phrase that you like to give back. So you served as you served as a contract professor for the microelectronics course at Milano Polytechnic. How has the teaching informed your perspective on leadership or product development?
You learn so much by teaching, you wouldn't believe it.
Okay.
So that was actually a very fulfilling opportunity that ST Micro offered. Right, ST had a collaboration with the Milan Polytechnic, so they rotated some professor for the microelectronics course. And so it was a third-year course for the full engineering degree, and so I was blessed to hold that course for 2 years, and in a way that was one way to give back, right? And in many ways, for some of these students, it was the first time that they actually get to do some hands-on laboratory experience. And in that case, it was simulations of digital and analog ASICs. Because that's, when third year is kind of when you stop doing a lot of theory and you're actually starting to do
the
real
practical
stuff. And it was so fulfilling for me to bring some real life, cases, some real life problems, and for them to engage and see actually what designing for a semiconductor really looks like.
Right. And then, of course, looking back from yourself coming out of the University of Pavia and the Marcellino that you are today, if you could turn time back to that young man, he's still young, but that really young man, you could turn back to that time, what advice would you give that person? What would you give that Marcellino that was at 21 years old in Pavia?
It's so hard. I mean, well, one thing for sure is opportunities don't happen by themselves. They are created by, one, your willingness to actually make something happen, and two, the network that you build. I probably, at least at the beginning of my career, didn't spend too much time on developing a network. And of course, it's easy to say here when you're in Silicon Valley, when you're so close, so where you are part of the network itself. Right. But that was probably, even though Milan is an economic center also for semiconductors, still I didn't probably fully leverage the networking opportunities that my job at the time offered. So maybe I would say, do a little bit more outreach earlier in the process. I think you're a master in this, right? That's your job.
I make the joke. I say to people, I would say, listen, they say your net worth is your network. Yeah. And I said, I have a huge network, but it's not my net worth. To be honest, it's no comparison. Now, from a future outlook point of view, one of the key things that I do see that is actually popped up, and I have one of them, is the momentum of AR and VR. And now, of course, we've been talking, it was from the MEMS days, I would say, we've been talking about these autonomous vehicles as well. Which emerging technologies do you genuinely believe will be the most significantly impact or demand on MEMS product innovation today?
Well, you touched on some technologies that probably taking more time than what we expected to get to that inflection point of rapid growth, AR, VR, autonomous vehicles. But there are some other, and that will happen, right? I'm sure that will happen once we figure out really the driving economic forces. When we will find some use cases that makes it worthwhile to carry your glasses, right? That enhance your productivity or your life in a way that makes it useful for you to actually go out and buy these glasses. So I'm seeing in 2025, I'm seeing the first signs of use cases that will make this happen, which touched about audio enhancement, right, being one of them, but also constant, always-on displays that help you navigate through life, not just the streets, but through life. And so that will happen eventually. I'm also seeing robotics is by definition another way of connecting the digital world to the physical world. These machines have to move, right? They need to navigate. They need to act on objects, so every joint in a robot needs a sensor. Correct. Right? Whether it's an accelerometer, a gyro, a magnetometer, a pressure sensor, so it's we're also seeing humanoid robots, right? And we are also realizing that it's very easy to make them walk, or at least it's a solved problem, but it's very hard to make them actually interact with things, pick up an object that is of unknown origin. So there's a whole lot of processing that needs to happen, from vision, understanding how or what this object looks like, and you can use also some MEMS technology as part of that vision. And then once you actually touch that object, then understand, not to crush it, but at the same time hold on to it well enough so it doesn't slip from your hand. That requires some maybe pressure sensors, and maybe some other kind of electrostatic sensors, and then the actual motion of picking it up and putting it somewhere. All these activities, they require a lot of sensing, a lot of high performance MEMS. So I'm bullish that these applications will be high users of our technology.
Do you feel that sometimes, when you look at the MEMS and its dependencies around other things? So let's talk about, you mentioned about humanoid robots, right? A lot of people fear that it's going to eradicate and take a lot of people's jobs with this agentic AI coming into place and etc. But this is all fancy and this is all great, and I think we will do it. But where are you going to find the battery life that will last 24 hours? Something simple like that, for example. This is actually, it's simple, but it's a huge problem, to actually make these humanoids work for so long. So my question to you is what can be done? Or is it necessary that the ecosystem as a whole gets together, or the whole supply chain combines itself to actually enable the growth of MEMS to actually happen and be realistic?
As MEMS vendors, we are just a small cog in a big environment, like you mentioned. So I'm sure that there's a lot to be done on the battery technology, on the power optimization of the whole system. Maybe the use case scenario. Maybe you don't need a humanoid robot that runs for 24 hours, or maybe if you have 3, they're running shifts, right? They can recharge, right? So even more sensors for us.
Which is a good idea. So it's inevitable.
It's inevitable. But, I don't want to focus just on humanoid robots, right? There are a number of factors that, so if, take the United States long-term commitment in becoming a manufacturing place itself. It's unlikely that it will happen exclusively through people, right? Because we already have almost full employment. So if you want to generate and build more and have more manufacturing, you inevitably have to look into robots, humanoid or none, right? You need to look into some kind of automation, and that again requires competence, right? It requires an improvement in the efficiency on how you make things. So your production is not just a human capital, but a full, human and technological capital that's being developed to make it happen.
Marcellino, it's been an intriguing discussion, but I really need to ask you 2 very, very important questions. What was the toughest part of your career?
Well, it's. I think this is true for many business developers, right, or any product manager. It's starting from a white piece of paper and putting together a business plan, a business scenario that then not only is it credible, but it's ambitious enough, but at the same time that you can navigate through the organization to make it happen. Right? Just having a good idea is not enough. And just being able to move the politics inside an organization is not enough. You need to have the balance on both. And sometimes it's hard to it's hard to develop what you're missing, right? Sometimes you have an open ear listening to you from your organization. Everybody's waiting, and you don't have a business plan to push, right? Or on the other side, you think you have this great idea, but you just find it hard to communicate. So this is definitely. It's not a single episode, but if I look at my job, this is the hardest thing that I sometimes face.
Is there do you have so this happens regularly? This happened regularly in your career?
It's as business developer, my job is to not look at the current technology, but maybe look 2-3 generations out. So you have to see what people are not seeing, because there's not smart or anything. It's because that's not their focus, right? They're focused on the here and now, and your job is to look further, right? So this happens regularly as part of my job.
So then on a positive note, what's the proudest moment of your career?
Well, are you in for maybe a couple of minutes of a story?
Please. I love stories. This is what we're about.
Depending on when this podcast airs, right? So for 13 years, I've also been a paramedic.
Wow.
So I've as a volunteer paramedic. That's one of the things that you do in Italy. Most yes.
Pre-pandemic.
When I was studying, from when I was studying at college all the way to after I got married. So it was a 13-year thing where at least once a week I would spend one night on call. Running ambulances, both as an EMT or as a driver. And one of the problems that we often had was the how hard it was to find the floor where people were in. So some people will call you, they will give you the address, you would show up, and it's say 12-story building. And they didn't tell you which floor they were on. And maybe you're in the middle of the night, you have to go around buzzing a number of, and so you waste time. And in some cases, as you very well know, any minute counts between life and death.
Right.
So fast forward to when I came to Bosch, I realized that we had a pressure sensor that we were trying to sell into phones that can actually detect an altitude change of less than 1 foot. So the accuracy there is through that pressure sensor, if correctly used, you can find which floor the phone is in. Mm-hmm. So through that idea, through a patent that I wrote on this application, and through the working with some partners that would implement a service so that when you make a 911 call, now that not only does it give you the last known GPS position, which is the entrance of the building, but also the altitude.
Wow.
The first responders now can get to the caller much
faster.
Quickly. And according to the FCC, that in the end accepted to roll out this service, in the US alone, more than 10,000 lives are saved every year.
What? Because of that pattern
because of that pattern, because of that pain that I had.
Wow.
So this actually closes the circle completely.
Wow.
And this is undoubtedly one of my proudest moments because of.
Wow, that's insane. Wow. So you can imagine just during the pandemic. I mean, that must have been a game changer.
Not just during the pandemic, right?
Before as well.
What floor are we on? So I don't know if I had to call right now the 911. You brought me in this.
They won't. So just because of that sensor, they'll know exactly where you
will know where I am.
Wow.
And not only that, right? Not only is it personal pride, but thanks to this, now every smartphone in US has to have a pressure sensor. So it's excellent business for Bosch.
Wow.
So good business, good vibes, saving lives,
I hope you got an award from that, from Bosch or something like that. I mean, that is revolutionary.
We're working on that. I hope my
That is
managers are working.
really remarkable. Marcel, is there anything that you would like to share to the audience? Something that, your personal journey or the future of invented for life solutions? Is there?
I often, I often help out some startups that are coming in the area to find new business, and oftentimes, again, it goes back to what I mentioned before. Try to network. Don't be afraid to ask for help, because without, if you don't ask, people will not know that you need help, and therefore, if you raise your hand, you're going to have a long list of people who are helping you. So that is the takeaway that I always give.
Reach out.
Reach out. Yes.
There are many friends out there in the industry. There's a lot of people that will help you out in this industry. That's the beautiful thing about our community.
Yes,
is you're surrounded by geniuses and highly paid geniuses. You get the fortune to rub shoulders with these individuals, but there is this humility whereby everyone helps each other. Yes. And if you ask for it, if you don't ask for it, if you don't ask, you don't get. And I think that is one of the beautiful messages.
It's one of the beautiful sides of our industry.
Oh, absolutely. Like, I mean, even when I took my sabbatical last year, I said I was done, but you still had people. I still had people reaching out, and that is, I don't know. As we say, like as you guys, in the army, there you have this brotherhood and sisterhood around, and that is the beautiful thing about the industry. So, Marcel, we have a tradition on this podcast where the last interviewer leaves a question for the next interviewer, and the question that is left for you is unfortunately the following. What is your strategy plan with the tariffs and the geopolitical situation today?
That's an easy one. so all multinational companies are struggling with tariffs, because tariffs are not conclusive to a seamless supply chain, and arguably, again, it's hard to find supply chains that are more complex than semiconductors. So for us, it's a big challenge. However, the bigger challenge to this is uncertainty. So if we knew once and for all what the tariffs would look like, and I'm sure that as an industry, we would plan around it to make it. The trouble is, we don't know.
You don't know what's going to happen in 1 hour.
Yes, exactly. Earlier this week, I was at an internal meeting, and we had our manager who deals with the government affairs, and they say that not only do their slides have a date, but they also have a time. So whenever they give a briefing on recommendations or what was going on, it said this. And by the way, these slides are updated on X date and 10 a.m. 10 a.m. because maybe at 11 some things are changing. So that is the challenge that we're dealing on right now. It's not the tariffs. It's definitely the uncertainty.
The uncertainty, right? Marcellino, from a personal perspective, aside from that, thank you. As you mentioned, thank you for your support that I've had with you pre-pandemic, during China, in the China days. It's been an absolute pleasure to know you. And to the guests out there, an audience watching the show, if you want to contact Marcellino, here's his LinkedIn profile. Right below, you can click, reach out to him. Thank you for tuning in to the Semiconductor Leadership Podcast. It takes a chip to raise a village, but this is why we do this for you, to give you the guidance from great leaders like Marcellino and many more in the industry. Thank you for tuning in, and see you next time. Bye for now.
Thank you.
Thank you, Marcellino. Thank you so much. It was a pleasure.